Okay, Resit practice paper, question number 2. Here we've got to try and find the root of this equation above here. And that means where it cuts the y-axis, because we're after, so where it cuts the x-axis, because we're after where x equals 0. So in other words, if I plot the function, and in the actual question, you won't get this diagram, but you can see that we've actually, if you look at the x-axis, which is here, one place where it cuts the x-axis, and that's between points 3 and 4. What you're asked to do is to show that there's a root between the values of 3 and 4. And so what we're relying on is the fact that if there is a solution between 3 and 4, then between 3 it must go from negative, so it's negative value when it's at 3, to a positive value up here somewhere when it's 4. In other words, it switches signs between 3 and 4. So all you have to do to prove that there's a solution is to put in x equals 3 and x equals 4 and show that one gives a negative solution and one gives a positive. Now for part B, we're going to use this numerical method, Newton-Raphson's, to come up with an exact value for this root, or an approximate value, and the more we do it, the closer we get to the exact value of the solution. And here is Newton-Raphson's method underneath here. And if you look at Newton-Raphson, what it tells us is, bring it up here, that to find a new root we need an answer, so we guess an answer, and then we subtract the value of the function at that value, at our guess, divided by f prime, which stands for the first derivative at our guess. So that will then give us a new value for x, and then we put that in back into Newton-Raphson and get another solution, and so on. So it's an iterative process. We have to continue to use it until we home in on a value. And our first guess is going to be somewhere between 3 and 4, because we know the root lies between 3 and 4. So guess 3.5, halfway. So we're going to let R1 equal 3.5. So we come up with our first solution for R1. Now, we're going to need the derivative for this bit, the f prime bit. So we've got to take our function. So the function is the function of x is given, and that's, we've got 3x cubed minus 10x squared plus x, I think, it's not yet, minus 14. So it's not an equation, we don't write equals 0, we're now actually got the function. And we're actually after the value of x so that this function equals 0. That's the whole idea of it. So now we've got to find a derivative. So the first derivative, f prime, take the derivative of each of these parts of this function. You remember how to do that. You bring the power down, times it by the number in front, and take one off the power. So that becomes 9x squared minus 20x. Derivative of x, because it's 1 lot of x, just becomes 1. So that's plus 1. And constants disappear. Remember, the derivative of 1x is 1, so whatever number is in front of here, it would be that number. So if it was 2x, it would be 2, so on. So this is our derivative. So now, using Newton-Raphson, our next root, our next guess, if you like, the value for the root is the original value minus the value of the function at our first guess divided by the value of the differential at our first guess. So let's put some numbers in. So our first guess, remember, was 3.5 minus, now I have to work out what the value of this function is when x equals 3.5 and the value of the first differential when x equals 3.5. So that's when I get my calculator out and work out what each of these is. I can try and do this in one hit on the calculator. I can put 3.5 minus, then use a fraction button and write this on top. So 3 times 3.5 cubed and so on. So, or I can do it step by step on the calculator and work out what the value is. So let's try putting the values in. So 3 times 3.5 cubed minus 10 times 3.5 squared plus 3.5 minus 40 over 9 times 3.5 squared minus 20 times 3.5 plus 1. Work out what that is, and that will give you R2. And then I repeat the process. I put my value for R2, whatever that comes out to be, back into Newton Maths. In other words, I've replaced each of these, the 3.5s, my first guess in other words, by my new guess. And you should find that gradually your answer will be the same, and then you know you've got the root. And if you look at the question, it says keep going until you get the same answer to 3 significant figures. So have a go, and I'll do it myself and then see if we agree. Okay, I've had a go, so I worked out what this was. I have to subtract it. It came out to be a negative number, minus 0.0106, which means that actually I've got to add. So the root must be nearer to 4 than 3.5. So 3.5 plus that gives me 3.606. That now becomes my new guess. So I'll replace in Newton Raphson 3.5 with 3.6. So 3.6, 3.606, 3.606 goes in. Work out what that comes out to be. That gives me a smaller difference, 5.285 times 10 to the minus 3, or 0.00, oops, it's not 0.00, so it doesn't like it, 528, in other words 3.601. That actually is correct to 3 significant figures. Oh, no it's not. Our original guess, what was that, 3.61, isn't it? So, yeah, so you've got to do one more. So put 3.601 in and find out what that is, and that gives us, if we compare that to that, rounded to 4 significance, it's the same answer. So in other words, we conclude that our root is about 3.601. And as a check, we could put that value in and see if we get a 0 into the original function. Okay, I'll stop there. Question 2.